Hello. Let's solve this Harvard University interview exam question. It's a tricky question, and I want us to solve this question. Many will not know how to start to solve questions like this, but let's check it out. With the laws of indices, we can find out the answers to this question. Now we are going to look at how we can simplify this in order to have a complete solution. We are given 8 to the power of 9 minus 8 to the power of 8, and we are asked to provide what the solution will be. Now I want you to recall one maths expression, the law of indices, that if you have a to the power of x plus y, that this will be equal to a to the power of x multiplied by a to the power of y. Now let me simplify this. This expression is now going to give me 8 to the power of 8 plus 1, which I know will give us 9, minus 8 to the power of 8, and then this will give us a solution. Now if I simplify this applying that law of indices, you find out that this will give us 8 to the power of 8 multiplied by 8 to the power of 1 minus 8 to the power of 8, and this will give us what we're looking for. Now if you simplify this, you find out that 8 to the power of 8 is common. We'll bring out 8 to the power of 8, and then all of these divided by 8 to the power of 8 will have 8 to the power of 1 remaining, which is equal to 8. 8 to the power of 8 divided by 8 to the power of 8 will give us 1, and this will give us the solution we are looking for. 8 minus 1 will give us 7, so we'll have 8 to the power of 8 multiplying 7, and this will give us what? Now what do we do from this point? From this point now, I want you to draw your mind back to a law of indices. And I'm going to break this down before we apply that law of indices. The value of 8 can be equal to 2 to the power of 3, right? So at that point, I can say I'll have my 2 to the power of 3 all to the power of 8 multiplying 7, and this will give me what? Now, take your mind back to a law of indices. If you have a to the power of x multiplying an external power of y, this can be equal to, this can still be equal to a to the power of x what? Y. So that external power will multiply. So we'll have 2 to the power of 3 multiplying 8 multiplied by 7, and this will give us what? Now if we simplify this, we're going to have that expression to now give us 2 to the power of 8 times 3 is going to give us 24, right? So we'll have that to give us 24, 24 multiplying 7, and this is going to give us what? Now if we look at this, I can still break down this. If I break down this, 24 can still be equal to 12 multiplied by 2, right? If 24 gives me 12 multiplied by 2, so this will give me 2 to the power of 12 multiplied by 2. All this will multiply 7, and this will give me what? Now, according to the law of indices, I can take any of these into a power. If I have a to the power of xy, this can be equal to a to the power of x multiplied by the power of y, right? If I apply that here, this is going to give me 2 to the power of 12, right? All will multiply the power of 2 multiplying 7, and this will give us what? Now in this expression, I want you to note something. You should note that it is normal that when we have 2 to the power of 10, 2 to the power of 10 will give us 1024. That's a unique number, right? Now what will 2 to the power of 12 give us? 2 to the power of 12 is going to give us 4096, right? That will give us 4096. So if we apply it there, we're going to have that expression to now give us that expression. Since we have 2 to the power of 12 in 2, we can break down that expression to give us 2 to the power of 12 multiplied by 2 to the power of 12. It is squared, multiplying 7, a way of expanding that, and this will give us what? Now if we expand that thoroughly, we will now have that expression to give us 4096 multiplying 4096, and this will be multiplying 7. This will give us what? Now look at that expression properly. If you look at that expression properly, I can simply simplify that expression. That expression I can simplify by looking at 4096. If I break 4096, that will give me 4000, right? 4000 plus 96, right? And I don't want to use my calculator. So at this point, what I'm going to do is I'm going to simplify this, and this part will now give me 4000 plus 96, right? The other part will give me 4000 plus 96, and this will multiply 7. This will give me what? If I simplify that using algebraic formula, now if I use algebraic formula, that expression is going to give me, using an algebraic formula, I want you to recall that algebraic formula. It's like we having from this expression 4000 plus 96 all squared. Now if we do that and simplify that, I'm going to have, using algebra, I'm going to have 4000 square, right? If you remember the law of algebra, plus 2 multiplied by 4000, right, multiplied by 96, right? That is the second part, and this will be plus 96 square, and all of these will be multiplying 7. And if we simplify this, we're going to have our expression to now give us, simplifying this, 400 square will give me 16000, right? 000 plus 2 times this will give me 8000 multiplied by 96 plus 96 square is going to give me 9216, right? 1296, and all of these will be multiplying what? 7. So if we do this, we are going to have this expression to now give us 16,000,000, right? Plus this is going to give me 9. This times this will give me 76800, right? 0, because we have 3 zeros, plus this is going to give me 9216, and all of these will be multiplying 7, right? And this is going to give me this. Now what I'm going to do is to add all of these. If I add all of these, that expression will now give me 16,000,000,000. Put them in their place value. The next one I'll have 76800. The next one I'll have 9216. So if I put them in their various place and I add, that expression will now give me 0, 0, 0, and 6 will give me 6. 0, 0 plus 1 will give me 1. 0, 0 plus 2 will give me 2. 9 plus 8 is going to give me 17, right? We'll write 7, carry 1. 1 plus 6 is going to give me 7. 7 plus 0 is going to give me 7. And then we'll have 6. And then we'll have 1. So our result is going to give me 1, 6, 7, 7, 7, 2, 1, 6, multiplying 7, because we have all these multiplying 7. So we're going to multiply finally 1, 6, 7, 7, 7, 2, 1, 6, multiplying 7. So if we multiply this, we're going to have this expression to now give us 7 times 6. 7 times 6 is going to give us 42. We write a 2 and then we'll carry out 4, right? 7 times 1 is 7 plus 4, that's going to give us 11. Then we'll write 1 and then carry over 1. 7 times 2 is 14 plus 1 is going to give us 15. So we'll write a 5 and still carry over 1. 7 times 7 is 49. 49 plus 1 is going to give us what? 50. We'll write a 0 and then we'll carry over 1. 7 times 7 is going to give us 49. 49 plus 5 is going to give us 54. So we'll write a 4 and carry 5, right? The next 7 times 7 will give us 49. 49 plus 5 is going to give us 54. So we'll write another 4 and carry over 5, right? 7 times 6. 7 times 6 is going to give us 42. 42 plus 5 is going to give us 47. That's, we'll write a 7 and carry over what? 4. 7 times 1 is 7 plus 4, that will give us 11. So the solution to that expression given to us up there will have 8 to the power of 9 subtracting 8 to the power of 8, and this will be equal to 117, right, comma 440, right, and 512. And this is the solution without the use of calculator to that expression given to us up there. So you see, very easy. Without the use of calculator, we can simplify that Harvard interview exam question without using calculator. I know you did enjoy watching this maths solution. Don't forget to give it a thumbs up, share it with friends and colleagues, and remember to subscribe to my channel for more simplified maths content. Thanks so much for watching.